Welcome back to Third Eye Weekly. Today we're here with Brian Nosek, Executive Director of the Center for Open Science. Thank you so much for joining us today, Brian.
Happy to be here. Thanks for having me.
Awesome. So for those in our audience that don't know, tell us a little bit about what the Center for Open Science is and the kinds of work that you do there.
We are a nonprofit tech startup, and our mission is to increase openness, integrity, and reproducibility of scientific research. So we do that mostly with software development. So we have a team of about 45 full-time and 15 interns, and about 2/3 of those are software developers building the Open Science Framework, which is at osf.io. It's a free open source tool for researchers to manage their data, make it more reproducible, register their designs, and share it more publicly if they wish to do so. And then we have initiatives to try to change the incentives in science to reinforce the ideas of transparency and reproducibility as being something that's good for me, a practicing scientist, while also being good for science. And then we do meta-science projects. So we try to study the process of doing science effectively and how we can make things more reproducible.
Nice. So you founded the organization along with Jeffrey Spies back in 2013 after implementing the Open Science Framework. What was that period like, and what is Open Science Framework?
So it emerged out of just projects in the lab. So I'm a faculty member at the University of Virginia, and Jeff was a grad student in our program and is in the lab. And he was a software developer prior to coming to graduate school in quantitative psychology, so behavioral statistics. And the project for the Open Science Framework emerged as something that we've been batting around for a number of years to try to figure out how can we make it easier for researchers to manage their own data, their own research materials for their own use, but then also make it really easy to make it available for other people. And he got excited about it and decided, I want to do this as my dissertation project, build a software tool to make this possible. That's a very unusual project in a psychology department to build software as a dissertation. But we built in a lot of psychological theory and practice into how it is you build a system that people want to use, would get value out of, et cetera. And so it ended up being a very interesting project. And then it got some early press attention. And then funders started calling and said, we think this is interesting. We said, so do we. And they got interested enough to say, well, why don't you start an organization so that you can really promote and develop the Open Science Framework in order to be something that provides a public good infrastructure for the scientific community. So we founded the Center for Open Science in January 2013, as you mentioned, and then we got our first grant in March, and then we started hiring people, and now suddenly we're a big group.
Nice. So how many scientists would you say are currently making use of the Open Science Framework?
Well, it's on our wall right there. So it's 12,167 today. Wow. And it's growing at a clip of about 50 people a day in the recent history. And we have a number of new features coming online that we think is going to accelerate that growth relatively rapidly.
Right. So why is open source important in the scientific community?
That's a good question, and there's a few different answers to that. One is that openness is fundamental to how science operates. The way that scientific claims get made, get wrestled with, get sorted out to what is good evidence and what is not good evidence, is a function of open communication of the basis for making those claims. How is it that we arrive at those claims? What are the data? What's the process? What's the materials? So openness is fundamental to the scientific process as a process. Open source, the software, actually has lots of great models for how science can be done, but it isn't being done right now. Most of science is done closed, right? You don't know what happens in my lab because you don't observe what's in my lab. All you see are the reports coming out of my lab of things that we did. And those really are just advertising for the research as the research process, something that David Donahoe at Stanford coined. And so what we're trying to do is make that entire process all the way down more transparent so that you can really evaluate what it is that we did. And the open source community has really mastered this in terms of a process for doing collaborative research openly, right? So instead of research on trying to solve scientific questions, the open source software community is building tools in an open collaborative fashion. So really our organization is just pushing these two things together. The practices of the open source community with the principles of how science is supposed to operate, so that we can have a fully open stack of what science is, right? The process of doing science on an open system that is free and open source. If we owned the open science framework as our intellectual property, then what we would confront are things that are conflicts of interest between what's good for us at the center and what's good for science, right? Oh, we need to make money from this. We need to clamp things down. Oh, this data is valuable. We're going to sort of grab on and own it. So we do no closed source development at all. Everything we build is free and open source, so that it's always feeding that public good aspect of this is infrastructure in order to help support and sustain the scientific community in general.
So this can help laboratories really organize their studies a lot better.
That's the real goal, is to make it so that I don't lose stuff for my own use anymore, right? What happens a lot in labs, and it's not just my lab where this happens, is that people go on to new jobs, right? Graduate students finish their PhD and then they go into a new lab for a postdoc and then elsewhere. And a lot of knowledge goes with that person, right? That person had her own organizational scheme, her experiments, her own data management practices, her own machine where all of that was stored. And so what used to happen is that a new student would come in the lab and we'd start talking, we'd get excited about an idea, and then we'd say, oh, this is just like this study that Nicole did a few years ago. Let's go get the stuff. And I would look on my machine, I can't find it. And say, oh, well, okay, I'll email Nicole. And she's out in industry, and so it takes 3 weeks of back and forth. So trying to figure out what study it even was, and if she remembered, she says, oh, I don't know where I stored all that stuff, blah, blah, blah. And this is just a huge waste of time. So the Open Science Framework is meant to eliminate all of that. Nicole does her study, she puts it on the OSF, she tags me as a collaborator so that I have access to the same thing. When that new person comes in, we say, that study, oh yeah, that's great, go get it, it's right there. And then it's so much easier for us to just manage our own materials, our own data, and also it makes it trivial for us to make it public if we want to. So a lot of that stuff never goes anywhere, but someone might get some value out of it. And so there's a little button up at the top of the screen for every project on the Open Science Framework. It says make public. So I can use it totally privately all the time. But if I decide to push that button, it says, do you really want to make it public? And I say, yes, I really want to make it public. And now anyone can discover that. And so the person down the hall that is trying to investigate the same kind of question can easily find materials that are relevant to their own research right there.
So in forming this process of just allowing an archive for all of this in one space, what were some of the important community relationships you have formed with the Center for Open Science in the past couple of years?
Yeah, this is really important because the ecosystem of science has many different contributors, right? And it tends to be very siloed. So there are different disciplines that have their own norms, their own cultures, their own infrastructure that they use. Different funding bodies have different priorities in terms of who they're funding and how. Each of the different journals has their own different kinds of practices. And then institutions and universities have their own systems of reward, deciding about tenure, all these other things. So all of these are contributing in a real complex network where me as a practicing scientist have to figure out, how do I succeed in this community? So what we are trying to do is really sort of be a communication relay station. All of these different stakeholders have lots of their own interest in mind. How can we sort of integrate them and try to solve the problems that are common across all disciplines? And so we've developed relationships with scientific societies like the American Geophysical Union, or the Association for Psychological Science, or the American Society for Cell Biology, right? All of them are working on very different problems, but they all have a common core concerns about access to data, access to materials, sharing of information, aggregation of knowledge. And so that's the role we're playing with them. Then with funders, all the funders want to see return on their investment, not necessarily in dollars, but in actually making progress on the research questions being asked. And so we've been doing a lot with NIH and NSF, and increasingly with some of the other organizations and some private funders like Sloan and Laura and John Arnold Foundation, to try to see if we can facilitate more of them getting the returns that they want. And then the last dimension, besides researchers themselves, that we've done a lot of work with, is trying to work with publishers and journal editors in particular. What is it that journal editors and journals can do to provide incentives so that authors like me who submit my paper also have a reason to make the data available, or the materials available, or pre-register my designs?
Excellent. Well, that's all the questions we have for today. Thank you so much for joining us on the show, Brian. It was a pleasure talking with you.
Yeah, thanks for having me.
Awesome. We'll be sure to send you a link to everything when it goes up on the site a little bit later this week.
Great. Thanks very much. Good luck with it.
Thank you. Have a great day.
And sorry about the snafus. I don't know why I wasn't getting
It happens with Google Hangouts.
We'll be able to edit it.
Good. All right. Take it easy.
Yep, see ya.
Bye.